All right, guys, so here's a quick video on graphing cotangents in case we get disconnected or something during Zoom tomorrow. So you can watch this and get the same stuff. So you guys, a cotangent is going to be very similar to a tangent graph. So this is where they get a little bit confusing. So remember that cotangent is the flip of tangent, right? So if tangent is sine over cosine, that means the cotangent is the flip of that. So the cotangent is going to be the cosine of x over the sine of x. And again, you guys, here we run into that problem with, oh my gosh, there's a denominator. We're going to have undefined things. That means we're going to have asymptotes. So we need to find out where this sine of x equals 0 so that we can find its asymptotes. Now, you guys, where does sine equal 0? Again, we go back to our quadrant angles. Remember, this goes 1, 0, 0, 1, negative 1, 0, 0, negative 1. This goes cosine, sine, cosine, sine, cosine, sine, cosine, sine. And where are sines equal to 0? Well, it's going to be here and here. So it looks like it's going to be at 0 and then pi, right? So we're going to have it equal to 0 and at pi. Now look, this never really stops, right? I mean, we can keep going around and go to 2 pi if we wanted to. We could keep going and even go to 3 pi, or we can count in the other direction and then go like negative pi, negative 2 pi, negative 3 pi, etc., etc. Okay, so let's go ahead and put our asymptotes at those points. So let's see what this would look like. So definitely 1 at 0, let's start with that one. So at 0, we're going to have an asymptote. So we're going to have, and actually let me do that in a different color so it pops a little bit more. So we're going to have an asymptote here at x equals 0. And then we're going to have an asymptote at pi. Now, you guys, usually I would just put it right here, but that's going to make a really, really thin cotangent graph. So I'm just going to take it a step further and just put the pi right here, okay? Just to make my cotangent graph a little bit bigger. So at pi and then at 2 pi, okay, and then again we're going to have one here at negative pi and at negative 2 pi. All right, so you guys, looking at this one more time, kind of looks like how we started tangent, right? But remember, tangent hasn't had an asymptote, one tick mark to the right and one tick mark to the left. Cotangent actually has a asymptote right on 0 and then every pi after. So a little bit different, right? We can label these if we wanted to as well. The halfway points would be pi over 2 and 3 pi over 2. And then the halfway points here would be negative pi over 2 and negative 3 pi over 2. Okay, now how are these going to look? Now you guys, just like yesterday, how we had those 3 dots creating a tangent graph, we're going to have the 3 dots creating a cotangent graph as well. Okay, so let's go ahead and do this. Let's fill in some of these points just by plotting them. Okay, maybe we can start with the positive ones. Okay, now remember, we're graphing y equals the cotangent of x, which is really the flip of tangent. Okay, so I know that the tangent of pi over 4 is 1, the flip of 1 is still 1. Okay, I know that the tangent of pi over 2, what is that? That's up here, right? That's 0, 1. Okay, so look, the tangent is going to be sine over cosine, right? So that's going to be 1 over 0, but the flip of that is going to be 0 over 1. So this is going to give me a nice little 0. And then the tangent of 3 pi over 4, I know is negative 1, but the flip of that is also negative 1. So I'm going to have those 3 little points. And you guys, let me go ahead and put them on there and kind of see what happens. So, and then maybe I can recreate the rest of them just using a pattern. So it says that at pi over 4, I'm going to be at 1. Well, you guys, I know pi over 4 is right here. So at pi over 4, I'm up at 1. So that gives me my first dot over there. At pi over 2, I'm at 0, which is right there. And then at 3 pi over 4, I'm right here, and it's at negative 1. So you guys, this thing's going to be going backwards, isn't it, right? So it's going to be, instead of going up like a tangent, this guy's going to be going down instead. So I'm going to have this little graph curve going this way, the little curve going that way. Now, if you wanted to draw another cycle of this, you can either draw it to the right or the left. Again, it starts at the center, right? If you go halfway to the left, you're going to go up 1. If you go halfway to the right, you're going to go down 1. And you guys, we're just going to use this recreating a pattern here instead of plotting all those points, which is kind of a pain. Okay, try one on your own. Try one to the left. We're going to go halfway between the asymptotes, go halfway to the left, up one, go halfway to the right. Oops, that's wrong. Sorry. Go halfway to the right and then down one, connect your dots. And really try to practice like drawing those curves, okay? A lot of people end up drawing a straight line, which you would actually get points off for. All right, so this is what a cotangent graph looks like. Now, you guys, amplitude of cotangent, how high, how low, it goes up forever, down forever, so this is going to be a none. And what's the period? Remember, you guys, the period for a tangent and cotangent graph is the distance between the asymptotes. Asymptotes. Okay, so this one's a little bit easier to tell what the distance between the asymptotes is. Look at this one and look at this one. What's the distance from there to there? Really easy to tell. This is 0. This is pi. So the distance from 0 to pi is still pi. Okay, and you guys notice that the asymptotes, okay, start on the y-axis this time, and the distance between them is what we call our period. Okay, so in this case, that was pi. Now, look, let's see, what do you think negative cotangent would look like, okay? And you guys, I'm just going to kind of highlight it on the top. A negative cotangent is just the cotangent flipped over the x-axis. X-axis. Oh my gosh, I can't write today. Let's erase that. That looks horrible. Okay, there we go. It's just flipped over the x-axis. So if I were to go up here and flip this over the x-axis, let's do it in like a yellow, okay? Look, if I were to take this and flip it over the x-axis, it would just flip going down like that, right? If I would take this and flip it over the x-axis, it would go up like that. Now, do you guys see how kind of confusing that is? So this right here is the graph of negative cotangent of x, and that's super crazy because you know what? Starting to look like a tangent graph, right? And look, I'm going to summarize all of these together in a second so that you can see the differences between the two. All right, let's graph one that actually has some movement going on, okay? So let's look at like example 2 here. It says sketch 2 cycles of the graph y equals 2 cotangent 2x. Okay, so again, the a value here, and I should have had that written here, it's kind of annoying. The a value is still the 2, and you guys, that's still going to kind of label your y-axis, but when we actually answer the question, what is the amplitude, we're going to say none, because the cotangent graph and the tangent graph doesn't end at a value. Remember, it goes up forever, and then it goes down forever. Okay, now, what's the value of your b? Your b here is, again, 2, but you guys, this time, the period here is not 2 pi over b. Remember, we have a new formula, okay? For sine and cosine, the formula for the period is 2 pi over b. But for tangent and cotangent, the formula is just pi over b. So we're going to have something a little bit different on these. So this is going to be pi over b, which is really pi over 2. Now look, unlike graphing sine and cosine, where we just took this and made that the last marker on the x-axis, it's going to be a little bit different. This time, the period, the pi over 2, is the distance between your asymptotes. So look, you really have to know where these asymptotes are going to be. And this is how you tell. I'm graphing a cotangent. A cotangent graph, it's going to have its asymptote, its very first asymptote on the y-axis, always, no matter what. Okay, so look. Draw your first asymptote on the y-axis. There it is. I know it's going to be there. And then, you guys, the distance between the asymptotes, so where's my second one going to be? It's going to be at pi over 2. That's the next one because it has to be that far between asymptote to asymptote. So look, here's what I'm going to do. I'm going to label this guy pi over 2 and then draw the next asymptote right there because I know the distance between these asymptotes has to be pi over 2. Okay, that tells me that, hey, this label is going to be pi over 4 because it's half of pi over 2. Now look, I only really want 2 cycles of a cotangent, so you can either draw the next one here or you can draw it here. It doesn't really matter, but you guys, you really have to think less if you just draw it to the left because I know this is going to be negative pi over 4, this is going to be negative pi over 2, and it's going to be an asymptote here. Okay, now look, this was the hardest part of it. How do I finish the rest? Okay, well, I'm going to go ahead and pick a different color here. I'm always going to make a dot right smack in the middle of the 2 asymptotes. So look, right smack in the middle of the 2. And now I know a cotangent graph drops from the left down. So I'm going to go halfway between, and then how far up am I going to go? Well, that's this B value. Nope, not that value, sorry. That's this A value, right? I'm going to go up to, and then I'm going to go halfway in between, and I'm going to go down to, and I'm going to connect this to the best of my ability and try to make it a curve. All right, now this guy right here on the left, just make a photocopy of it, up to, halfway, down to, right smack in the middle. And there's going to be the cotangent to cotangent of 2x, okay? Now, you guys, really quickly, I am going to do a summary here for you. Sorry, this was an example I did with my other class. Okay, so look, a really quick summary, and I think this is really going to help you. Okay, so the first thing that we have to know, okay, is that A is going to tell you how far up and down. Well, no, let's not write it that way. That's going to be confusing. Don't worry about the A, sorry. Okay, the first thing we need to know is that our period, sorry, that was just going to be confusing the way I was going to say that. The period for these is going to get calculated with this pi over B, okay? Now look, let's look at a tangent versus a cotangent graph. I'm going to put them all next to each other so you guys know exactly what to do, okay? And also, you guys, the important thing, this is the distance between your asymptotes. Okay, now look, for tangent graphs, okay, we're going to have y, I'm going to look at y equals tangent of x, and I'm going to compare to y equals negative tangent of x. Okay, you guys, a tangent graph, remember that has one asymptote to the right of the y-axis and one asymptote to the left of the y-axis. And you guys, a tangent graph always goes right smack through the middle, okay? You're going to go halfway and then go up. How far up? Well, that's going to be your A value, whatever your A value is, and then halfway to the left and down, whatever your A value is, okay? So a tangent graph is going to look like this. And I'll show you a cool way to remember it in a second. Now, a negative tangent graph, what is that going to look like? Okay, asymptotes are still in the same place. It just kind of reverses direction. So a negative tangent graph still going to have one asymptote to the right of the y-axis, one asymptote to the left of the y-axis. And look, it's still going to go through the center, but it reverses its order. So instead of going from the bottom left to the top right, it's going to go from the top left. So when I go halfway, it's going to go up A units. And I'm going to go half to the right, and it's going to go down A units. So whatever that value was. So do you guys see how a negative tangent just reverses order? Okay. So look, and let me draw cotangents so that you can see the difference between the two, but they all look very similar, okay? So a positive tangent starts from the left and goes up, okay? And a negative tangent starts from the left and then just goes down. Now, how does that compare to a cotangent graph? And I think this is really going to help, like, seeing all of these guys together. Okay, so let's look at a cotangent graph, and dang it, we're not going to be able to see them all together, but it's okay. Okay, so let's say you had y equals cotangent x, and I'm going to compare it to y equals negative cotangent x. Now look, you guys, the main difference here between tangent and cotangent is where the heck are those asymptotes. Okay, remember a cotangent graph has its first asymptote on the actual y-axis. So the next one's just going to be, you know, one like tick mark to the right there, okay? And then you're always going to have your halfway point there, okay? So we're going to go ahead and go in the center. Now look, a cotangent graph, a positive cotangent graph drops down. So you're going to go halfway, and then you're going to go up to whatever the A value was, and then halfway and down to whatever your A value was. So it's going to look something like that. And now at this point you might be thinking, Miss Cruzy, that totally looks like a negative tangent graph. And look at it. Look at these two. Yeah, they look exactly the same. But what's the main difference here? It's the placement of their asymptotes. That's what makes the difference between a tangent and a cotangent graph, right? But look at negative cotangent. What the heck does negative cotangent do? Again, its asymptote is going to be on the y-axis, and then 2 big tick marks to the right. You can make it just one big tick mark to the right if you want to. Problem is then they're going to be really, really skinny. It's going to be hard to tell what's going on. Okay, again, we're going to go right smack in the middle to get my first point. Okay, and you guys, and when you put a negative in front, it just reverses the order of it. Okay, so halfway here, instead of going up, I'm going to go down A. So I'm going to be here. Halfway, I'm going to go up A. So it's going to be right here. So it's going to look like this. Okay, now you guys, the way I remember this again, look at negative cotangent and look at positive tangent. Don't those look exactly the same? Yeah, they look like they're exactly the same shape. However, it's their asymptotes that tell them apart. Okay, so it's going to be a big deal when we're going backwards from graph to equation, which we're going to do next week. Now, how do you tell, like, what's a cool way to remember where they start? This is how I remember it. Okay, I just remember that we have cotangent and tangent, right? C comes before T in the alphabet. So look, cotangent, tangent, okay? Tangent starts here, okay? That's where tangent starts. Unless it's negative, then it's flipped, okay? If it's negative, we just flip it, okay? Look at cotangent. If I write CT, right? C, this is where cotangent starts, and it just goes down, okay? If it's negative, though, it's just going to be flipped. That's how I remember them. I don't know if that helps you, but that's kind of how I remember it. All right? So, you guys, I hope that helped. We'll go over this on Friday together, so hopefully it'll be easier seeing it live. All right? Have a great